Hello, I'm Doug Brock, and today I'll be presenting our project, Forms of Sentience and Future Places, developed with Stanislav Roudavski, who leads the Deep Design Lab at the University of Melbourne. This presentation will explore the role of sentience in different forms within the context of future cities. We will start by arguing that future places and cities face a crisis caused by ecological and technological conflicts. Then we will demonstrate that while sentience exists at the intersection of biological and technical domains, these fields of research rarely work together. In this context, we see an opportunity to use sentience to integrate ecocentric and technocentric approaches to city futures as an alternative to existing urban planning. Our key question then is, what roles might sentience play in future places? In response, we hypothesize that a more than human understanding of sentience can provide interspecies justice in future places. We will explore this hypothesis by outlining two forms of sentience, biological and artificial, before considering sentience in the context of smart cities, and finally discussing the implications of expanded sentience in cities for more than human stakeholders. Visions of future cities differ greatly. On one hand, techno-optimists aspire towards cities that are long-lasting, resilient to change, and are good places to live. Smart cities like the recently cancelled Sidewalk Toronto are an approach where human designers propose to resolve urban challenges, including socio-economic inequality, energy consumption, and waste production, through the design of ubiquitous connectivity, sensing tools, the collection of citizen data, and AI algorithms for decision-making. On the other hand, environmentalists foresee extinctions in the twilight of consumer civilizations. Every year, human societies consume 1.5 times more resources than the planet can sustain. Anthropocentric practices have now left more than 75% of the planet's landmass significantly degraded, and current extinction rates for all species are up to 1,000 times the natural levels. Human activities are now the dominant driver for the planet's ecological crisis. As the population of the human species rises alongside expectations of living standards, so too does the consumption of water, the usage of energy, and the size of urban populations. In fact, smart cities and technologies are even propagating and accelerating the crisis-causing approaches. For example, the collection and processing of information in smart cities requires increasingly high volumes of materials and energy, leading to pessimistic predictions. In every future scenario, this technological acceleration will continue affecting physical, subjective, and social lives of both human and non-human city dwellers. Yet, current city models of sustainability, resilience, and livability seek to mitigate damage without straying beyond the status quo models. Evidence demonstrates the need for more radical alternatives. We approach this challenge through the lens of sentience. Sentience is a contested concept which sits at the intersection of ecological and technological concerns. The very broad range of disciplines that study sentience, such as philosophy, biology, ethics, computer science, and urban systems, among others, confirm its importance. Both ecocentric and technocentric discourses appeal to sentience in their efforts to describe improved futures. Technological approaches often equate sentience with smartness and seek to use it as a technological capacity to improve human lives and for financial or political gain. In contrast, ecocentric approaches refer to sentience because it's an attribute that triggers moral obligations that can guide biologists, ecologists, and ethicists towards justice for non-human stakeholders. Beyond this, we suggest that the exploration of sentience can challenge existing anthropocentric frameworks in future cities. Our framework proposes criteria that move beyond mitigation of harm through sustainability and livability for humans towards more ambitious targets that aim for thriving, more than human communities that are fair for all forms of life. Smart cities provide a useful test case because they attract so much attention and practical activity. This activity engages forms of both biological and artificial sentience, yet technical discourses on smart cities or sentient cities rarely consider biological sentience. Discussions of sentient cities tend to consider sentience as a capacity of the city, without linking it to other sentient entities. In the fields of biology and philosophy, there is discussion of non-human sentience, including its ethical implications. However, there is little consideration of artificial intelligence and robotics in relation to ecology. The disjointed character of the discourse prevents integration of scholarship on non-human self-organization, self-design, self-management, and subjectivity. The discourse in ethics, especially in animal studies, also suffers from an anthropocentric bias. For example, moral consideration based on sentience gives privilege to the types of sentience, feeling, and knowing that most resemble human sentience. These conceptual and practical limitations prevent contributions from non-human life forms, misrepresent the role and capabilities of sentience and smartness in technical systems, and therefore limits design's capabilities to imagine environments that support thriving communities in just and resilient ways. This focus on the different forms of sentience, their interconnection, and the implications for ethics requires further development. We see an opportunity to integrate and extend these existing bodies of knowledge on sentience. Unifying ecocentric and techno-optimistic discourses of sentience presents an opportunity to consider sentience in an inclusive manner, which will support better understandings of more than human communities and enable more participatory future places. Therefore, this paper asks, what role might sentience play in future places? And in response, we hypothesize that an understanding of sentience as a more than human, relational, and distributed phenomenon can promote interspecies justice in future cities. To test this hypothesis, this project outlines biological understandings of sentience in humans, animals, and other life forms, compares these against technical understandings and forecasts of artificial sentience, explores how biotic sentience and technical sentience combine in the context of smart cities, and discusses the implications for human and non-human stakeholders. There are two commonly recognized forms of sentience, biological and artificial. Both exist within cities and urban systems. Sentience is a contested concept with varying definitions. One example from biology is that sentience is the capacity to feel, in contrast to reason or logic. An ethics-based definition of sentience is the capacity to suffer and or experience enjoyment. Or, from the architecture discourse, sentience is the ability to be aware. In humans and others, sentience is a collection of characteristics, including emotions, feelings, and valences. Emotions like fear or hunger are useful as homeostatic guides for corrective behavior, regulating both an organism's internal conditions and its responses to external stimuli. Feelings are mental experiences of emotions or body states, like suffering or enjoyment, which organisms experience with positive or negative valences and varying intensities and persistence. These emotions, feelings, and valences are useful to an organism because they help to regulate homeostasis for survival. It is the valence of emotions which links sentience to ethics and interests. Sentience as a mechanism isn't perfect. Instead, it evolved to provide rapid and coarse guidance in overwhelmingly complex situations. Evidence increasingly demonstrates that sentience occurs in other biological species. For example, dolphins whistle after eating with a delay between eating and whistling, which is consistent with the delay for the release of dopamine in the dolphin brain, suggesting a positive emotional response. EU laws protect invertebrates such as octopus, based on evidence that they can experience pain, suffering, and distress. Insects also exhibit sentient capacities. For example, bumblebees show an optimistic and aroused emotional state after receiving an unexpected sucrose reward, and can also become depressed. Some researchers recognize sentience in non-zoological forms. Some plants have the capacity to respond to herbivory damage or changes in temperature and light by employing corrective behaviors, such as the release of pesticides or changes in the photosynthetic systems. Cells, such as Paramecium caudatum, can reverse the direction of motion when they bump into obstacles or encounter poison. More radical positions see sentience in all self-organizing systems that maintain self-identity. The expanding number of biological species suggests that sentience exists at different levels, in different degrees, and in different forms. Claims of artificial sentience are also multiplying. The current discourse in technical fields such as AI, robotics, engineering, or design often equate sentience with smart buildings, smart agriculture, and artificially intelligent information systems. Further claims of technical sentience describe the complex and dispersed technical intelligence within urban systems. Some describe this technical sentience as emergent rather than deliberate, coalescing from increased data analysis, self-referential performance, and the expansion of sensors and feedback. Others see a sentient city as a self-aware entity that is conscious of its relationships with its citizens and the environment as a desirable goal. More radically, some techno-optimists speculate that the realization of artificially sentient machines is within reach. In robotics and AI, some theorists speculate that accelerating technological changes will expand the range of sentient beings beyond the known biological species. But with this growing spectre of artificial intelligence or sentient machines, prominent voices such as Elon Musk, Bill Gates, or Stephen Hawking have raised fears that artificial superintelligence might pose dangers to human beings, including the risk of domination. There are differences and similarities between biological and technological forms of sentience. Both abiotic and biotic entities have bodies which sense and process information, make decisions, and come into relation with other sentient or non-sentient agents. However, artificial sentience is not equivalent to humans or other life forms because it has not emerged through intrinsic needs for survival and goal-oriented desires. Products of rapid and parochial design efforts, forms of artificial sentience are more arbitrary, fragile, and less integrated with or responsive to the other forms of sentience. Anthropocentric views of sentience limit sentience to humans. Bioethics extends sentience to animals, but stops short of more ecocentric views, which in turn exclude artificial sentience like robots or cities. Therefore, the common use of moral circles is persistently exclusionary and therefore problematic. Together with research in the second wave of environmental ethics, we propose to abandon the unhelpful analogy of circles with boundaries and see forms of sentience as overlapping, nesting, and interacting to form fields of codependent relations. Common conceptualizations view sentience as a capability which can be more or less valuable according to an implicit scale that presumes human abilities are the best or most deserving. This approach typically places human-like sentient entities at higher levels of moral status. However, this understanding of sentience rarely results in the recognition of codependency between sentient beings. It also fails to acknowledge that all existing forms of sentience have been successful simply because they have survived, in most cases for longer than human species, and often in places and conditions that humans struggle to or cannot tolerate. Therefore, we instead propose an alternative interpretation of sentience, as one way to conceptualize and describe interactions between biotic and abiotic others. We define sentience as an inclusive, relational, and distributed phenomenon. In nature, processes that resemble sentience are common, varied, and possibly omnipresent. Such an expanded and relational understanding of sentience can help designers move away from anthropocentric and techno-pessimistic approaches and towards ecocentric futures that can acknowledge and apply technical solutions without losing the necessary critical scrutiny. In smart cities, concepts of sentience are currently anthropocentric and techno-optimistic. For example, characteristics of the Smart City project Sidewalk Toronto included self-driving cars, self-heating pavement technologies to clear ice and snow, and the monitoring and regulation of stormwater using sensors and automated control valves. This image presents a recent depiction of the components of a smart city. In this vision, there is no mention of non-humans or the implications of sentience. Such approaches embrace technology but do little for ecocentric justice. In contrast, emerging frameworks within urban systems are beginning to expand to include non-human sentience. For example, our Deep Design Lab seeks to provide powerful owls with prosthetic nests to replace lost keystone trees. This multi-species design aims to re-establish missing links in the powerful owl's habitats. This approach needs to engage with sentience, traditions, and cultures of both humans and owls if these organisms of these species are to successfully live together. More speculative approaches consider the impact of sentient machines. Robots or artificially intelligent systems are likely to be common in future cities. Consequently, the relationships between humans and forms of technical sentient entities are at the center of designers' attention. However, the accumulative implementation of smart technologies means that technological systems will increasingly come into relation with sentient biological beings, potentially with widespread harm. According to the precautionary principle, all existing and potentially sentient entities, evolved or artificially constructed, deserve consideration. Prolongation of the prevalent anthropocentric understandings of sentience and technocentric strategies will lead to further exclusion of non-humans and accelerating environmental degradation. Current urban designs like Sidewalk Toronto, which require large-scale construction and technical manufacturing, are likely to worsen the situation. Alternatively, the focus on more-than-human sentience can help improve more-than-human justice by informing objectives, criteria, and techniques of design. For example, in smart cities, the collection of citizen data is used to regulate city systems like transport or water usage, but these citizens are normally exclusively human. Understanding that non-humans are also affected by issues of green space, movement through the city, or stormwater collection can help direct designers towards more ecocentric outcomes. A shift away from an anthropocentric focus can improve the futures of non-human city inhabitants, as in the case of the powerful owl habitats, which extend the benefits of technological practices to other species. In our interpretation, non-human subjectivity and the related phenomena that include knowledge, information, cognition, intelligence, and, in particular, sentience, acts as the key binding mechanisms that make life worth living for all life forms. As such, it deserves further attention from all who are responsible for planning, designing, and controlling the form and operation of future places. We began this presentation by arguing that future cities face ecological and anthropogenic challenges, and therefore alternative practices are needed. We proposed that one possible alternative is the concept of sentience, because it connects technological disciplines with discourses of ecological justice and value. Both technical and ecological fields appeal to sentience for improved futures, but these fields remain disjointed. Therefore, unifying the discourses of sentience presents an opportunity to connect biological and technological sentience. We questioned what role sentience might play in future places, and hypothesized that an expanded understanding of sentience can promote interspecies justice. Biological understandings of sentience extend to human, non-human, and non-zoological forms. Technical understandings view sentience as emerging from coalescing technological capacities, or are sometimes equated with smartness and seen as desirable goals. Both biological and artificial forms of sentience differ in how they have come into existence, but these differences do not preclude their inclusion. We propose an expanded understanding of sentience as inclusive, relational, and distributed. This expanded concept of sentience can help smart city designers move away from anthropocentric and techno-pessimistic approaches and towards ecocentric futures. An understanding of sentience as a more than human, relational, and distributed phenomenon can promote interspecies justice in future cities.